Hello, today's lecture is on Toxins Lesson 21, Neutralization Reactions. If you did the acid-base indicator lab with red cabbage, you know that the presence of an acid or a base can be determined with an indicator like the juice from the red cabbage. Indicators turn different colors depending on the presence of acid or base. You probably remember me putting dry ice in a slightly alkaline solution. The color changed from blue to green to orange, indicating the change from base to neutral to acid. I was showing you that to emphasize the point that the excess carbon dioxide in our atmosphere is causing our oceans to be acidified. Today's lesson is about acids and bases neutralizing each other. If you had acid indigestion, you might take something like Tums or Rolaids, a base, that would neutralize the excess acid in your stomach and help you feel better. From lesson 19, we learned that a water solution always has the same amount of H plus and OH minus. The quantity of these two always multiplies out to 1 times 10 to the negative 14. In pure water, you would have 1 times 10 to the negative 7 H plus, and 1 times 10 to the negative 7 OH minus. In neutral water, you'd have the same amount of each, and that multiplies out to 1 times 10 to the negative 14. But if the concentration of H plus and OH minus get too high, they come together to form water. So if you had an acid that had a concentration of 1 times 10 to the negative 5 H plus and 1 times 10 to the negative 5 OH minus, that multiplies out to 1 times 10 to the negative 10. And that's much greater than this number here. So there's too much H plus and OH minus. And these two will come together to form water, or the excess of this will come together and form water. When you mix the acid with the base, the concentration of H plus and OH goes way up, and the H plus and OH neutralize each other to form water, and that goes something like this. So here's our H plus, and here's our OH minus, and they find each other in water, and a bond forms right there, making H2O. So they neutralize each other. The plus and the minus neutralize each other. We end up with water from mixing H plus and OH minus. So here's a neutralization reaction. This is actually the first one in problem number 4 in your homework. Hydrofluoric acid combined with NaOH produce H2O liquid, that's liquid, and NaFAQ. So this is left dissolved in solution. But the H plus and the OH come together to make a molecule of liquid water. So keep in mind, this is real important right here. Acids reacting with bases always produce two things, water and salt. In this case, the salt was sodium fluoride, NaF. But always you will get water and you will get some salt. In this case, the salt is the ions left from the H plus and the OH minus. What happens if you add NaOH and CaOH2? Nothing happens because they're both bases. The OH from the NaOH and the OH from the CaOH2, they can't neutralize each other. They can't make water. So you would just have more base if you added one to the other. What happens if you add 5 moles of hydrochloric acid with 3 moles of NaOH? Now, neutralization takes place, but since you added more acid than base, only partial neutralization will take place. The 3 moles of acid and base will neutralize each other, leaving 2 moles of HCl unreacted. This solution will still be acidic. Now, this is a hint for question number... This is a hint to help you answer question number 5. All right. And that should help you with your homework. Have a great day.